today we will actually talk about the don't care. So and see what's the meaning of the don't care condition. Okay. So we start with one example. So suppose you have the function, I don't know, the function f is x, y, and z. So you have the truth table for this function. So it is actually 3x, y, z, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1. So then 0, 1, 0, 1, 0, 1, and 0, 1. And here you have the if. Okay, so suppose for this function, whenever all of these three input is 0, the function is 0. Whenever the x is 0, the y is 0, and the z is 1, it's 1. Whenever x is 0, y is 1, the z is 0. You don't care about the function will be 0 or will be 1. Okay, whenever you want to represent these kind of the situation which you don't care, so you actually put the x here. So what x means, so whenever I put x, so it means it doesn't matter based off your application. It could be if it's 0 or if 1, it's actually you are fine with both of them. Okay, so it doesn't matter. So it could be anywhere. So that it depends on the design that you have. So you could actually, this is another example. Whenever the x is 1, the y is 0, z is 1. If you don't care what should be the function f, you put actually x. So that means whenever you see these x anywhere, it means you could replace that x with the 0 or 1, depending on actually you. So how we could use these don't care whenever we use the k-map? The answer is, okay, x could be 0 and 1, but whenever you are dealing with the k-map, the goal is have the minimum number of the set and the number of the members is maximum. So that means depend on the k-map that you have, you consider x 0 on 1, and you should actually replace x with 0, 1, which will lead you to get less number of the sets with the maximum number of the members. So let's see how we could do that. Okay, so we let to have one example which is clearly shows what I'm talking about here. So let's to have this. So you have this function which is f x y z w. It is equal to sigma midterm. So these are the midterm 1, 2, 4, 5, 7, and 15. Usually whenever the function has actually the don't care, they represent the don't care with this, say, plus the don't care, and give a number of the don't care. You have in the 3 you have don't care, you in the 6 you have the don't care, and you in the 11 you have the don't care, and in 13 you have a don't care. Okay, so how you have this function with this midterm, which is the function in this midterm is 1, and in these numbers, these like the function is don't care. That means it could be 0 or 1. We don't care which each of, yeah, both of them actually works. Okay, so here we want to simplify function, and let to see how we could simplify and use a k-map whenever we have the don't care. Okay, so nothing actually changed here. So you again you have your k-map. So this is you have 4 variable, so it should be 16. So you put x, y here, zw here, 0, 0, 0, 1, 1, 1, 1, 0. Same thing here, 0, 0, 0, 1, 1, 0, and sorry, 1, 1 here, and 1, 0 here. Okay, so just put the numbers. So let's to have numbers for each of these squares. So definitely this is 0, this is 1, this is 3, this is 2. So then again you have here 4, 5, 7, 6. Here you have 12, 13, 15, and 14. And here you have 8, 9, 10, and 11. Okay, double check that. 8, 9, 10, 11, 12, 13, 15, 14, 4, 5, 7, 6, 0, 1, 3, 2. Okay, that's right. So then actually put the midterm. So midterm 0 is 1. So I have 1 here, 1, 2. You have 1 here, 1 here, 4. You have on 5. You have on 7. You have on 15. Okay, so these are the one. And see the don't care. Whenever you have don't care, I just put X inside the 3. So here is the X is a don't care. What else you have on the 6? You have the don't care. Then what else we have? 11. So 11 is here. And the 13 is here. Okay. So this is actually what we have. So actually we did a mistake here. So let's fix that. So see, this is 8. This should be 11. This should be 10. Okay. So that's wrong. So let I fix that. This is 8, 9. You plus that with 3. So we should have here, you should have 8 plus 3. You should have 11 here, and should have 10 here. Okay. So if we fix that, so we have what we have 15, 5. We don't have 10, 11 here, but here we need to change that. So that I do that. So we have 3, 6. We have 11, which is the here, and the 13, which we already have this. Okay. So we don't have any things on the 10. So I need to get rid of that. Okay. So just double check. We have on 3, we have on 6, we have on 13, and we have on 11, right? 4 don't care based on whatever you see here. And you have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that's right. So this is what you end up. The everything is same. The only actually difference is here you put don't care actually X. Okay. So now we need to actually similar with the what we had so far. Just you are looking for the sets which the minimum number of the sets and their member should be the maximum. So see here you have the X, here you have the X. You could replace these with X with the 0, and also you could put with 1, right? We don't care about that. So if you don't care, I put actually these X1 and these X1 that help me have a one set of 8, right? So that's what I did. So I consider these two X, which is this one and this one, as a 1. So then I could actually have one set with the 8 members. So this is how we use the don't care to end up with more simple sentence. So how about these X? What I need to do with these X? Consider this as a 0 or 1. These X that you see in the 11. So it could be, yeah, definitely. If this is 1, I could actually cover these one and have 1, 4, right? So see, I could, if I consider these as a 1, you should have another 4 here, which has helped me to get the set with more members. How about these X in 13? I consider that as a 0 or 1? No. So see, if it is 1, the rule is the number of the sets should be minimum. If I put this 1, I need to put that inside another set, which is I have just 2. Okay. If I consider this 1, so then I will have 3 sets, which is this number of the sets should be minimum, right? So definitely I considered X as a 0. So that means I don't need to put this inside any other actually sets that we have, because if I have this one, I need to consider another set, which is the number of the set is not going to be minimum. But here the minimum number is 2. I have one set with the 8 and another one with the 4 members. I don't need to actually have 3. I consider these x as a 0, which means you don't need to cover that x here. So that means you have 2 sets, one with the 8 member. Just write the corresponding term for each of these sets. So this one here is, again, z and w changed to the 0 and 1. So that means you don't have any zw. Check the x. X here is 0 to 0. It should be the prime. And the y is 0, 1. It should be eliminate plus. That's the only things that you have for the set with the 8 members. So how about the set with 4 members? So the x and y changed to 0, 1. It should be gone. And the zw actually is 1 and 1. So it should be zw. Okay. So this is actually the simplest form that you could have for this function. So as you could see, everything is same with the K-map that we already saw, but the only difference is whenever you have the don't care, somehow you use that don't care that help us to end up the minimum number of the sets and the maximum member inside that sets, okay? So any question? So let you have another example for the don't care, which is we have the pmux term. Okay, so this is another example. You have function f, which is the function of x, y, z, w. So it is equal to pmux term. Usually you don't need to have these here, just this symbol is enough. So this is the Mach term numbers. So the Mach term number is 1, 2, 5, 11, 1, 2, 5, 11, 13, and 15. Okay. So be careful whenever you have the Mach term. Yeah, that means the function standard form is the product of the Mach term. You don't say plus because you don't have the plus in the Mach term. Mach term is the product of the Mach term, right? So you say dot or times d and the number of the don't care, which is here is 0 and 0, 3, 6, 9, and 10, and 12. Okay. So this time the function is in the second standard form, which is the product of the Mach term. Okay. Again, we want to simplify this function and get the simplest form of our function. So as you already know, you just get the Carnot table. So you have 4 variables. You could have the K-map with 16 square inside that. So you actually put x, y here, z, w here, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay. So you have 0 here, you have 1, 3, 2. So you have 4 here, 12 here, and 8 here. You have 5, 13, 9. You have 7, 15, 11. You have 6, 14, and 12. Okay. Sorry, 10, not 12. So you get rid of this. Should be 10. Okay, let's. Okay, so I don't know what's happened here, but Yeah, something. Okay, so that I see. Wait, what's. Yeah, that's actually should be to do that again. Yeah. Yeah, I think my pen got some problem here, which is somehow just. Yeah, for some reason it's not be. Okay. Yeah, we have some problem here so that I see. Okay. Yeah, for some reason my pen doesn't work well. Just that I give me a few minutes that able to fix this. Okay. So yeah, I don't know what's wrong with this. But that I actually opened another page. Probably it's able. Yeah, it's actually fixed that. So I have to go to the. I don't know what's. It shouldn't be like this. But to see. Okay, I think right now it's fine. Okay, so here we have actually 12. Okay, so let's just adjust the page a little bit. Okay. Okay, we are good. So you have some mux term. Just be careful here. We have this is a mux term, right? Whenever you have the mux term, these mux term is 0, right? So you check which mux term you have here. You have the 1, which is you put 0 here. You have 2. This is not min term, so that's the reason that mux term I put 0. We actually talked about that in our last class. So 1, 2, 5, 11, 13, and 15. These are my mux term. And don't care is here on the 0. You have on 3. You have on 6. You have on 9. You have on 10. So yeah, this should be 10. 10 is actually, this one is 10, okay? So this is 8 plus 2, you have 10. So this is 10. You actually correct that. This should be 10. So you have in 10, and finally you have on 12, okay? So just double check that. So we have 0, 0, x. We have 3, 1, 0 there. Yep, it's fine. So now I give you a few minutes. You tell me how we could actually get our sets here with using these don't care, which is 0 and 1. And the idea is we should end up with the minimum number of the sets, and their members should be the maximum, okay? So you tell me what we need to do. Could we actually make any sets with 8 members? Yes or no? No, that's definitely right. So how about the 4? How many sets with 4 member we could use? So we actually have 3. Yeah, that's right. Should be 3. So let's to see where is that 3. So the one is obvious. So see, I consider these actually these 2x as a 0. So that means this could be 1, 4. Okay. So if I want to cover these 0 that I have, so I have 1 here, I could consider these 9 in the x in the square 9 should be 0, and I could get another 4 group. So now the only things left is these two zeros, so I consider these whole as another 4. So how about these x that we have on 6, 10, 12? I consider that as a 0 or 1 for the x that we have on 6, the x that we have on 10, and the x that we have in 12. They should be 0 or 1. Definitely 0, because if you have 1, you need to put inside one set. So definitely your number of the set is going to be more than 3, because right now you have a 3, you cover the all zeros. Okay, so if you consider that as a 0, sorry, if you consider these x as a 0, right, you need to have another sets we cover this, so that means the number of the set will be more than 3, which is not good. We want to number of the set will be minimum. Definitely the is x should be 1. I consider this 1 because this is a Mach term, right? If this is 1, this is 1, this is 1, so that means you don't need to have any sets to cover these 1. You just put the zeros inside the sets. Okay, so that means these 6, 10, and 12 should be 1, and these x in the 0 and 3 and also in the 9, we consider that as a 0. So again, the x means we don't care. You could have 0 or 1, but you use them to actually end up with the minimum number of the sets and the maximum number of the members inside. So we have 3 4, so I write actually 3 4. So then you actually able to write the corresponding terms for each of them. Start with this. So the z and y is going to change to 0 to 1. They are gone. So the x is x is 0, y is 0. You tell me what should be the corresponding term for this. Just be careful. This is a Mach term, not min term. So see, it should be, you tell me, the x plus y. The format actually is a Mach term. So that means you consider x plus y plus z plus w. So because that's a Mach term. So then whenever they have 0, no prime, 1 is prime. This is actually exactly the opposite of the midterm. So then the next one. What should be the next one? Consider these set with 4 members. So again, x and y change. You have 0 and 1. 0 for a z, which is a z plus, and the w is a 1, which is get the prime, omega prime. Okay. So this is for this one, and finally you have this one, which is the 4. So again, you check x and y. The x is 1 and 1, should be x prime, right? And the y is 0, 1, it should be gone. The z is 0, 1, gone, and the omega is 1, which should be omega prime. Okay. So you have x plus y, z plus omega prime, x prime, omega prime. Okay. So this is another example which shows how you could use the don't care.